Recall in previous videos we talked about the product property of radicals that says if I'm multiplying two radicals together, I can bring them together under the same radical, meaning if I have two square roots being multiplied, I can multiply the radicands, so a times b, together underneath that same radical, and vice versa. I can go the other way. I can take that radical and the product or the factors underneath and split them up and simplify them individually. So we're actually going to use this piece today to simplify radicals that are not perfect squares. Starting here on the left-hand side, we have the square root of 32. The square root of 32 is not a perfect square, so I'm going to break it up into factors. 32 is 8 times 4. 8 is 2 times 4. 4 is 2 times 2. And 2 times 2. So it's really important to pay attention to the index. The index is the root here. So there's no number here. This is a square root versus something like this where it's a cube root. You can have fourth roots or fifth roots or sixth roots because that tells us what we're looking for. So this square root says I need something times itself. So here's 2 times 2. 2 times 2 and a leftover 2. Anything that is a perfect square, I can take the square root of. So I'm just going to take 1 minute to rewrite this. So 32 is the same thing as 4 times 4 times 2. And I got those 4's from our buddies here, our terms that are being multiplied by themselves, the pairs. And if I check that, 4 times 4 times 2 should give me 32 back where I started. Now 4 is a perfect square, so I can take the square root of that. So using this property above, I can actually split it up into square root of 4 times the square root of 4 times the square root of 2. And then simplify. So square root of 4 is 2. Square root of 4 is 2. And then I have this square root of 2 that I can't do anything with because 2 itself is not a perfect square. I multiply those 2's together. 2 times 2 is 4. And I end up with 4 square roots 2. Now you don't have to show all those steps if you notice the pattern here. I have 2 squared, so when I take the square root, it comes out as 2. 2 squared, square root of that is just 2. So I have 2 underneath the radical. When I take it out, I just have 1 because I have taken the square root. I have undone that square. Anything without a perfect square will stay underneath. Okay. Go ahead and try the 2 on the right-hand side without any variables. So factor it. Pay attention to this one's a square root and that one is a cube root. Okay, so we're starting here with the square root of 216. I'm going to start by factoring that. 216 is the same thing as 2 times 108. 108 is the same thing as 9 times 12. 9 is 3 times 3. 12 is 3 times 4. And 4 is 2 times 2. For a square root, I'm looking for pairs. Here's a pair of 2's and a pair of 3's. And I can't do anything with this singular 2 and singular 3. So anything with a pair, I can take the square root of. The square root of 3 squared would be 3 from here. Square root of 2 squared is 2 from this pair. And I have a 2 here, 3 there that do not have a pair. They're not perfect squares. They have to stay underneath the radical. and I multiply anything I can. So 3 times 2 is 6. 2 times 3 is also 6. We get 6 square root 6. Alright, the cube root of 40. Again, I'm factoring 40. 40 is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. Now I'm looking for cubes. Something times itself 3 times. I see 3 2's. I can take the cube root of 2 cubed and get 2. This 5 is not a perfect cube. It'll stay underneath the radical. And again, make sure you're putting back this 3 here to show it is a cube root and not a square root. Alright, now let's try the same thing with variables. Alright, in the previous video we talked about if I had something like the cube root of x to the 12th. We know that we're looking for something times itself 3 times, so we're splitting it into 3 equal parts. We can just take the 12 and divide it by 3, and that would give us x to the 4th power. So essentially this will only work if the 3 divides evenly into that 12, right? So whatever that index is, I need multiples of that number for it to divide evenly. Looking at this example here, we can see that 3 will not go into 13 evenly. 3 would go into 9 evenly. So y cubed is a perfect cube, and we can take that whole thing out. The w to the 13th, we can't take all of that out because it's not a perfect cube. But I can break this up. So I'm looking for the closest multiple of 3 that's less than 13. So the closest multiple would be w to the 12th, right? So multiples are 3, 6, 9, 12, 15. 15 is too much, so I go back to 12. If I'm using 12 w's to get that w to the 12th, that means there's one w that's not accounted for, because I have to have the 13 that I started with. So I could rewrite this as the cube root of w times w squared times y to the 9th. Right? This is all multiplication. And anything with a multiple of 3 exponent, I can take the cube root of. The cube root of w to the 12th, 12 divided by 3 is 4, so w to the 4th power. Then the cube root of y to the 9th, 9 divided by 3 would be 3. We get y to the 3rd power. And lastly, this 1w was not a cube, so I can't take it out. It stays underneath the radical. Go ahead and try the one on the right-hand side. Okay, same idea here on part C. We want the cube root of x to the 11th times y to the 7th. I'm looking for the closest multiple of 3 that is under 11. So 3, 6, 9, x to the 9th power. And if I'm using 9 x's, how many are left over to get me back to 11? So x squared. 9 plus 2 is 11. Same thing with y to the 7th. I need the closest multiple of 3 that's less than 7. That would be 6. So I can split that y to the 7th into y to the 6th times, if I'm using 6 of them, that means I need one more to keep it to the 7th power. I'm still taking the cube root of everything here. So the cube root of x to the 9th, 9 divided by 3 is 3. So that would be x cubed. So this one is a multiple of 3, can come out. This one's a multiple of 3, can come out. So the cube root of y to the 6th now. 6 divided by 3 is 2. We get y squared. Cube root of anything that's left over. I have a x squared. A square is less than a cube. I can't take it out. There's no perfect cube there. Times, there was 1y, so times y. Okay. Now let's go ahead and throw in coefficients and variables all together. Pay attention to the index. This is a square root. We are looking for pairs, something times itself. I'm going to go ahead and factor 27 into 9 times 3. 9 is 3 times 3. There's a pair. This one stays underneath the radical. If I want squares, I'm looking for multiples of 2. 2, 4, 6, 8, 10. So this m cubed is not a perfect square. But I can break that into m squared times m, right? If I had 2 m's from the m squared times 1 more m, that's m cubed, which is what I started with. Into the 4th power, that is already a perfect square. So an even exponent, that's a perfect square. I need to not forget this m and this p here when I simplify. Those terms that do not have perfect, or a buddy, that are not perfect squares will have to stay underneath the radical. So let's start with coefficients. The square root of 3 squared would just be 3. So from here. We have this m squared. The square root of m squared is m, assuming that m is a non-negative real number. Then the other m stays underneath. N to the 4th. The square root of n to the 4th. I take 4 divided by 2, which gives me 2. So n squared. The square root of n to the 4th is n squared, because n squared times n squared gives me n to the 4th. Now I look at anything that didn't make it out of the radical. I had a 3, an m, and a p. And that should be as far as you can go. Again, everything underneath the radical is being multiplied. So when we take things out, everything is still being multiplied. Let's look at one more before you try the examples. What do I do if I have a number on the outside of that? In this case, 5th root. Remember, a number next to parentheses, that means times. A number next to an absolute value, that means multiply. Now a number next to a radical also means multiply. So I'm going to not forget that this 7 is being multiplied here. That is not 7 to the 5th power. That is the 5th root of 32x to the 8th, y to the 15th. So we've already simplified the square root of 32, but now we're doing the 5th root of 32. So again, pay attention to the index. If you don't, then it's really going to mess up your answer. So 32, we already said 32 was 8 times 4, 2 times 4, 2 times 2, and 2 times 2. So I have 5 2's. 1, 2, 3, 4, 5 2's. 32 is 2 to the 5th power. And I'm looking for multiples of, go back to this index, 5. I need multiples of 5 to be able to take the 5th root of it. So 32 itself is something times itself 5 times. 2 times itself 5 times would give us 32. So this whole thing is going to be able to come out. Then we look at the x to the 8th. Again, I need multiples of 5 in the exponent. 5, 10, 15, 20. So the closest multiple is x to the 5th power. And then how many does that leave left over? X cubed. So I took 5 out of that. There's still 3 left over. It has to add up to that x to the 8th. And y to the 15th, that is a multiple of 5. I don't need to do anything with that exponent. Now let's evaluate it, or simplify it, I should say. We still have that 7 out front. Don't forget it. It's very easy to forget it. Then we have the 5th root of 32, which was made up of 5 2's. So the 5th root of 32 is just 2. Then the x's. I have the 5th root of x to the 5th. 5th root, 5th power, they undo each other, and I get just x. Right? So the 5th root of x to the 5th is just itself, just x. And for the y, y to the 15th, 15 divided by 3 would be, 15 divided by 5 would be 3. So that comes out as a y cubed. Because y cubed times itself 5 times would give us y to the 15th. Now we check for anything that does not come out. This is a 5th root, and I took this out. I did not take an x cubed. Again, remember, I need at least 5. A 5th root, I need 5 of them to be able to take them out of that 5th root. And then one last step, I simplify. 7 times 2 is 14. X, the y is cubed. Then I have the 5th root of x cubed. Please make your answer pretty clear for me on your tests, so I know what is an exponent, what is a root. Just like over here, this looks kind of like 7 to the 5th power, but it's not. It's 7 times the 5th root of all that stuff. So I like to kind of extend my root out a little bit, so I make sure that my 5 is really in there in that groove, and it's clear that that's a 5th root. Go ahead and try the 3 on the right hand side and see how you do. Part D on the right hand side has 3 times the square root of 18, a to the 4th, b to the 5th. This is a square root. We're looking for pairs of numbers or variables when we simplify this. So I have to factor that 18. 18 is 2 times 9. 9 is 3 times 3. Here's a pair. That's going to be able to come out. I have a to the 4th. Since we are looking for a square root, we're looking for multiples of 2 in the exponent. A to the 4th, 4 is a multiple of 2. This is a perfect square. It can come out entirely. B to the 5th, 5 is not a multiple of 2. So I have to simplify this a little bit. B to the 5th is the same thing as b to the 4th times b. Right? So 4 b's here, 1 b there, gives me b to the 5th, which is what I started with. And that b to the 4th is a perfect square and can come out. This b is going to be stuck underneath the radical. So let's simplify. I still have this 3 in front. Don't forget that. So 3 times. I'm taking out a 3 from my 18. Square root of 3 squared is 3. I'm taking out all the a's. A to the 4th, 4 divided by 2 is 2. So a squared. Times, taking out this b to the 5th, or b to the 4th. Same thing, 4 divided by 2 is 2. I get b squared. What's left underneath? I have a 2 and a b left underneath the radical. We take one last step and multiply everything we can. 3 times 3 is 9. A squared b squared square root of 2b. And that's as far as we can go. Alright, the fourth root of 32z to the 7th. Fourth root, we are looking for groups of 4. I need a fourth power to be able to take the fourth root. 32, we've factored it several times now. 32 is made up of 5 2's. I can only take out 4 at a time because it's a fourth root. So there's going to be 1 2 stuck underneath the radical. With that z to the 7th, I'm looking for multiples of 4. The closest multiple of 4 would be z to the 4th power. And I need 7 z's, so that means there's 7 to the 3rd power left over. This can come out. The z cubed is going to stay underneath the radical. Again, the fourth root of 2 to the 4th power is just going to be 2. The fourth root of z to the 4th will be z. And then we check anything else that's left underneath. So I still have the fourth root of 2 times z cubed. So these pieces that did not have a fourth root were left underneath the radical. Then that would be as far as you can go. Just make sure you don't forget that 4 in your answer. Alright, last one here. I have the 6th root of 192 x to the 7th, y to the 14th. So I'm going to go ahead and factor that 192. That's 2 times 96. And then divide by 2 again. That's 2 times 48. 8 is 6 times 4, or 6 times 8. 6 is 2 times 3. 8 is 2 times 4. And 4 is 2 times 2. Looking for 6. This is a 6th root. I need 6 things, or I need 6 factors that are the same being multiplied together. So I have 1, 2, 3 2's here, and 1, 2, 3 2's here. So there's my 6 2's. I can take the 6th root of 2 to the 6th power. Now it would just be 2. I look at my x's. Again, the 6th root. X to the 7th is the same thing as x to the 6th times x. There's 7 x's. And then y to the 14th, again, I want multiples of 6. So that's the closest multiple to 14 of 6 would be the 12th. Y to the 12th power. If I'm only using 12 there, that means there's 2 y's left over that are not part of the 6th power. They don't have 6 of them. You can't take them out of that radical. Circle everything I can take out. I can take out an x to the 6th, a y to the 12th. I cannot take out the x or the y squared. I already took out my 2, and the 6th root of x to the 6th is x. The 6th root of y to the 12th, 12 divided by 6 is 2, so y squared. Still the 6th root of anything left over. Starting with my numbers, I had a 3 here. That's going to have to stay underneath the radical. Then I had an x here. Has to stay underneath. And a y squared. Yes, a y squared can stay underneath. Let me rewrite that. Because we're not looking for perfect squares. We're looking for something times itself 6 times, which none of these left here under the radical have. This would be as far as you could simplify it.